This video will be about graphing radical functions. So when we are graphing a radical function, we are focusing on first what's called the parent graph. So if we're focusing on just square root of x, the parent graph for square root of x starts at 0, 0. The next point is 1, 1. And the next point is 4, 2. And you do need to know what those points are in order to do some of these shifts and shrinks and things we'll be doing to our graph in a little bit. So that's our parent graph. It's our function that we base off every other thing we do to the graph. So what you can do to this graph is you can move it up or down. That's called a vertical shift. You can move it left or right. That's called a horizontal shift. You can stretch it or shrink it, and you can flip it upside down. So each of these have a particular spot on our basic equation that will tell us, okay, this is a vertical shift or a horizontal shift. So if it's a vertical shift, it's a number added to the end of our equation. So if we say plus k, if our number here is positive, that means we will shift up. If it's a negative, that means we will shift down. For example, let's say we have f of x equals square root of x minus 1. Notice the square root symbol ends before the minus sign. It would be different if that square root symbol continued. So minus 1 is a negative number. That means we're going down 1 unit. It means we're going to take every point on this graph and move them down 1 space. So that's why it's important to know where your parent graph is, because those are kind of our reference points to help us get our new graph. Now, if you're unsure if you did something correctly or not, you can use a graphing calculator. You probably don't have one at home. If you do, great, go ahead and use it. If you don't, there is an online graphing calculator called Desmos.com. At Desmos.com, you could create an account if you want. That makes it so you can actually save graphs and stuff. Or you can just go to Launch Calculator. So on this online calculator, here is where you'll enter your equation. So you can enter the whole thing, y equals square root, our radical symbol is down here, x. Now we do have to go to the right of that. Right now, if I put minus 1, it would end up underneath the square root symbol. So we need it to be to the right of the square root symbol. And it shows it's moved down 1 unit. Now, it does look like it's been moved down 2 boxes, but that's just because the way they've labeled everything. To get to the value of 2, you have to go 4 boxes. So to get to the value of negative 1, you only go 1 box. But you can check your points by hovering over. They'll have some key points highlighted. But this can be a very useful tool so that you can check and make sure you've done your graph correctly. Now, it won't help you with every problem because some problems you're just going to ask, well, did you move up or did you move down? So those ones you have to know, well, this number means, hey, we're going to be moving down. So the next kind of movement that can happen with your graph is a horizontal shift. So a horizontal shift happens when you have a number inside your square root. And it's kind of opposite of what we expect to happen. If you have a positive number underneath your square root, it actually means move left. If it's negative, that will mean go to the right. So if I had f of x equals square root of x plus 3, that would actually be telling us, since we have a positive 3, to go left 3 units. So let me draw in my axes. Our parent graph starts at 0, 0, 1, 1, and 4, 2. Like I said, it's important you get those points kind of memorized or have them in your notes or something so that you always know where they are. And then it says move each of those left 3 units. So starting at 0, we would count 1, 2, 3. There's our first one. Then the next point we count 1, 2, 3 spaces. Then the next point, 1, 2, 3 spaces. So there is our function in purple. The red function is just our reference point. It's our parent graph that we can use to figure out our final answer, but the final answer is the purple graph. And again, you can check your work by graphing it on the online graphing calculator. Now what if we have both at once? Let's say we had f of x equals square root of x plus 1 minus 2. That means we're going to be doing 2 movements at the same time. So negative or positive 1 means go left 1. It's opposite of what we expect. Positive means go left. And then outside, this is our vertical shift, our up or down. Negative means go down. It's exactly what we expect. So our parent graph was 0, 0, 1, 1, 4, 2. Our final answer, we have to go left 1, down 2 with each of our points. Left 1, down 1, 2. Left 1, down 1, 2. And that gives us our final picture. So there's our basic shifts, our horizontal and vertical shifts. We can also do what's called a stretch or a shrink or a flip. On our basic parent function again, if there's a number in front of the square root, it's going to tell us whether we shrink, stretch, or flip. So if A is bigger than 1, that means we have what's called a stretch. If A is between 0 and 1, basically if it's a fraction smaller than 1, it's a shrink. And with both of these, we could also have a flip. If A is negative, our graph will flip. So we could have a stretch and a flip or a shrink and a flip. It's possible that both of those can happen together. So for example, let's say f of x equals 3 square root x. Now again, this is where our original parent graph, those points really come into play. We have the point 0, 0, the point 1, 1, and the point 4, 2. Now what this 3 in front is going to do is it's going to change the y values of those points. So we are stretching because 3 is bigger than 1. That means it's kind of going to get bigger and taller. And when we stretch, to do that, we multiply each of the y values to get our new point. So our first point would be 0, 3. So we start at 0 up to 3. Our second point would be 1, Obviously, I was adding in my head instead of multiplying on that point. Hopefully you caught that. If 0 times 3 is 0. So we still start at 0, 0. I apologize for that. Second point, 1, comma 3. So there we go, right 1, up 3. And last point would become 4, comma 6. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So that made the graph a lot taller. Now, even if it's a shrink, the idea is still the same. We just have to multiply the y values by a to figure out what our new graph would look like. So let's do an example. Let's say f of x equals negative 1/2 square root x. So we have 0, 0, 1, 1, 4, 2. This time I'm going to put the points above because our graph is going to shrink. It's going to be going below our original. So we know this has a flip. We know our final graph should be flipped upside down because it's negative. And we know it's a shrink because 1/2 is between 0 and 1. So we have to multiply each y value by negative 1/2. If we multiply it by the negative, it's going to automatically flip it for us. So 0, comma 0, because 0 times negative 1/2 is 0. So our first point. 1, comma negative 1/2. 1 times negative 1/2 is negative 1/2. So we go right 1, down 1/2. And 4, comma 2 times negative 1 is, 2 times negative 1/2 is negative 1. So 4, comma negative 1. So our graph has both flipped and it's shrunk down some. So that's the basics of working with a radical function. Now there's a second type of radical function you may be asked to graph called a cube root. So a cube root is this kind of equation. There's a 3 in that little check marky spot. It is not in front, it's in the check mark area. So the cube root of x, we need to know the basic graph so that we can then graph all of the rest from that. So the parent function for the cube root, the key points are 0, 0, 1, 1, negative 1, negative 1, and 8, 6, 7, 8, 2. 8, negative 8, negative 2. So it's kind of an odd picture, but it looks like that. That is called the cube root. And let me label those points for you. These are our key points that will help us draw the picture from our parent graph. Now it follows all of the same rules that we did with our square root functions. The only difference is we're starting from a different parent graph. And now let's try a problem where we have more than one thing going on at a time. Let's have all of the stuff going on. So let's say we have 2 times cube root x plus 1 plus 3. So looking at this, we know 2 is positive, so no flip, and it's bigger than 0, so that is a stretch. We know 1 is positive, but it's under the square root, so that's our horizontal shift. I'm just going to write HS for horizontal shift. And since it's positive, we know we're going to the left one. Remember, the horizontal is always opposite of what we expect. And then our 3 is our vertical shift. It's also positive, but that's going to tell us to go up 3. So when you're graphing this, it's probably easiest to do the stretch first and then worry about the horizontal and vertical shifts. So when we had a stretch, we knew we multiplied every y value by 2. So we get some new values. -8, comma -4, -1, comma -2, 0, 0 ends up staying the same, 1, comma 2, and 8, comma 4. So now we got a whole lot going on this graph already. I'm going to get another graph in here so that we can actually plot the new function without having quite so much going on. So our new points were -8, -4, 3, 4, 5, 6, 7, 8, down 4, -1, comma -2, 0, 0, 1, comma 2, and +8, and +4. So that's not quite our final answer because we still have to do our horizontal and vertical shifts. Horizontal shift was left 1, vertical shift was up 3. So from each of these points, we're going to have to move left 1, up 3. So we count left 1, up 1, 2, 3. Left 1, up 1, 2, 3. Left 1, up 1, 2, 3. Left 1, up 3. And left 1, up 3. And then we draw our completed graph in. So that would be our final graph. Again, if you need some help, go to that online graphing calculator. So we could erase what we have written, or you can go to number 2 and draw a second graph. We have y equals, and then it was 3 times the cube root. Now notice, none of these functions have that little 3. There's the square root, but there's no little 3 in the check mark. So you have to go to these additional functions, and we want to be on the miscellaneous tab, and then we can do cube root of x plus 1. And then I just realized that that front number really should have been a 2. So x plus 1, and then it was plus 3 at the end. I was remembering the 3 at the end. So here, they have the picture, and you can go check it against your graph that you drew to see if they match. And again, if you need to, you can kind of, it's hard because of the tablet I'm using, but you can hover, and it will show you some of the points. My tablet does not hover very well. But you can check your points with what's on this graph. So you can check your points by hovering. My tablet does not hover the best because I'm using a pen instead of a mouse. So it will let you hover though and check which points are actually graphed. So there's only one more thing we need to talk about with graphing radical functions. When you're graphing a radical function, the last thing we need to talk about is if they give you an equation that looks like this. So they're going to give you some instructions saying to rewrite and identify transformations. Transformations is a way to say the horizontal shift, the vertical shift, the stretch, the shrink, or the flip. So in order to rewrite this, what's different from what we've seen before is now we have a number inside the square root in front of that letter x. We actually don't want that there. So from those terms under the square root, we're going to factor out that number in front. So when we say factor, factor is a fancy form of division. So let me get rid of that on my screen. So under the square root still, we're going to take out the 9. We want the 9, and then we're going to put parentheses, and we have to figure out what's left inside the parentheses. To do that, we actually divide each of those by 9. 9 divided by 9 cancels, and you're just left with the letter x. 27 divided by 9 is negative 3. Then we still have the minus 5 at the end. So that's still not quite written the way we're used to. This 9 should be outside the square root, not inside. So now what we're going to have to do is we're going to have to square root each piece individually. Square root 9 is going to be separate from square root of x minus 3. Then we actually take the square root of 9. The square root of 9 is 3, because 3 times 3 equals 9. And now we have a graph that we can, or an equation that we can identify the graphing transformations from. So we can identify our horizontal shift, vertical shift, and stretch shrink, or if we're flipping. So negative 3 inside was our horizontal shift. Horizontal shift is opposite, so negative actually means to go to the right. So horizontal shift is right 3. Vertical shift is that number outside negative 5. It's negative, so that means go down 5. And that 3 out front is bigger than 1. It is not negative, so there is no flip. Because it's positive, there is no flip. It's bigger than 1, so we have a stretch. So sometimes they'll ask you to actually draw the graph, and sometimes they'll just ask you to list the transformations. So that concludes our discussion on graphing radical functions.